Hi there. So I'm going to answer your question. It's on page 182, question 10 and 11, I believe. Okay, so our question is, determine the exact volume and surface area of a right pyramid with a height of √3 feet and a hexagonal base with 6 sides of 2 feet. Okay, so first of all, what we need to know is, what does exact volume mean? So exact means only fractions or simplified radicals. As soon as you have to round, it is no longer exact. Okay. All right. So we've got a hexagon base. Now it is a regular hexagon. Now excuse my very crude drawing here. Give me 2 seconds. I'm just going to copy what I had done originally. Okay. And in order to find the area of the base of a hexagon, what we're going to do, and I'm going to do it in red, we're going to draw triangles. So I've got one here, got some here. Okay. And the measurement for that is 2 feet. Okay, so if this is 2 feet, I'm just going to mark it with a 2. If this is 2 feet, and this all the way around, and this is a regular hexagon, okay, that means that this angle has to be 60, 60, 60. If all 3 angles are the same, then this has to be an equilateral triangle. So that means that this length right here is also 2. So if we know that, then we can find the height of one triangle. Okay, if we know that this is 2 and this is 2, we can find this height right there. Okay, so this is h. We need the height of the triangle in order to find the area. Okay, so what we're going to do is use Pythagorean theorem. Now, what we need to understand is this whole thing is 2, but this from here to here is 1 unit. Okay, so I'm going to use Pythagorean theorem. So that is going to be 1 squared plus, I'm going to call this h. H squared is equal to 2 squared, because this is my hypotenuse. H squared is equal to 4, take away 1. H squared is equal to 3. Therefore, H is equal to √3. Okay, so I've got the height of the triangle. Okay, so area of the base I have 6 of them. Actually, I'm going to do this differently. Hold on. So I have 6 triangles. So it's going to be base times height divided by 2. So it's going to be 2 √3 divided by 2. So base times height, so 2 times √3 over 2. Okay, so I can cancel out my 2's here. And the area of the base is going to be 6 √3. Okay, so that's my area of the base. Okay, So why don't we find the volume? Because we know the area of the base and we know what the height is, okay? And we know that for the volume of any pyramid, it's going to be 1/3 area of the base times the height. So 1/3, or I'm just going to go 1 times the area of the base, which is 6√3, times √3 for my height, divided by 3. So the volume is going to be, I don't have to worry about the 1. I'm going to go √3 times √3, which is 3 times 6. So that's going to give me 18/3. My volume is going to be 6 feet cubed. Yeah, 6 cubic feet. Okay, so that's my volume. Now we're going to do the hard part, which is the surface area. Okay, so I found my area of the base. Now, what we have to imagine is that this is a pyramid. Now, I don't know if I'm going to be able to draw that kind of pyramid, okay? So let's imagine that I've got a face here, a face here, and a face here, face here, face here, face there. I know that its height is √3, okay? So what I'm going to do is the following. So I am going to draw a right triangle Now, this height is √3. This is the height of my pyramid. I hope you can follow this. It's really hard for me to draw a pyramid on this. So this is my height of my rectangle, or my pyramid. We found this, just a minute here. I just have to kind of picture this. Give me 2 seconds here. I'm going to pause for a sec just to get my orientation down. All right, so if this is my height, this is my face, I know this length right here, which was √3. Okay, so now what I can do is I can find this hypotenuse right here. Okay, so this is going to be the face of the pyramid. Okay, and we know that it is 2 feet right there. Okay, that 2 feet. Okay, so what I'm doing is I am finding this right here for the face, not the base. I've already done that. Okay, so we're going to have here, again, Pythagorean theorem. So √3 squared plus √3 squared is equal to, I'm going to call this A. Okay, so A squared, altitude. So this is going to be 3 plus 3, which equals A squared. This is going to be 6. So √6 is equal to A. All right, so that means that this is √6. So now I could find the area of this triangle, base times height divided by 2, and then I'm going to multiply it by 6. So area of 6 faces. So that's going to be 6. Let me fix that. So 6 faces base, so that's 2, times root 6, so it's going to be 2 root 6. Let me fix that. 2 root 6 divided by 2. So my 2's are going to cancel. And then the area of the 6 faces is going to be root 6. Or 6 root 6. So 6 root 6. Those are the area of the faces. And then what I'm going to do is I am going to add the area of the base plus the area of the 6 faces. So area of the base was 6 root 3. Area of the 6 faces was 6 root 6. Okay, and that is going to be the exact surface area of the pyramid. Okay, I hope that this makes sense. It's really hard to do it on the smartboard, especially drawing a hexagonal pyramid. Oh, let's try question number 11. Okay. In 1989, a glass pyramid expansion was built at the entrance to the Louvre Museum in Paris. The largest pyramid has a height of 70 feet and a square base with sides of 115 feet. The pyramid consists of 603 rhombus-shaped and 70 triangular-shaped glass segments. The base of the pyramid is not glass. The Muttart Conservatory in Edmonton consists of 4 square-based pyramids. One of these pyramids has a side length of 19.5 meters and a height of 18 meters. To the nearest 100 square feet, how many square feet of glass is the pyramid at the Louvre? Okay. Okay. So let's draw this out. So we've got a square pyramid. I'm going to draw the base. Now we're not including the base because it is open to below, okay? So not terrible, but not great. So here's my pyramid, okay? And it tells me that the pyramid has a height of 70 feet. So I have 70 feet for my height. My sides are 115 feet. So wait, I'm going to pause because I think I just got a package. Hold on. Okay, so we need to figure out what the area of this glass face is. Okay, so what happens is I've got a right triangle right here. Okay, so let me draw that out. Right triangle right here. So this is 70. Now the whole thing is 115, and half of 115 is 57.5. Yeah. So now I can find the hypotenuse. So let's do that. So we're going to get s squared. I'm going to call this s. Now with the magic of having done this on a separate sheet, my side length is going to be the square root of 8206.25. Now, I'm not taking the square root of this. I'm going to worry about it later. It'll help me with the rounding later on, okay? So we want to the nearest 100 square feet. Okay. So we've got 4 triangular faces. So my area is going to be 4 times 115 times the square root of 8,206.25 divided by 2, and it gives me an area of 20,800 square feet. Okay, now how many times as great as the volume of the pyramid in Edmonton is the volume of the pyramid at the Louvre? Okay, so the first thing that I'm going to do is I'm going to find the volume of the pyramid at the Louvre. So volume, I'm going to call it L for Louvre, and it's going to be 1/3 times the area of the base times the height. So 1/3 times 115 times the height, which was 70. Oh, wait, 115 squared because it's the area of the base. So squared. The volume of L is 30,000, or no, 308,583 and 1/3 feet, cubic feet. So CUFT, cubic. All right, now we need to figure out the Edmonton one. So give me just 1 sec. I got to do a little bit of converting here, and I'll show you what I'm doing in just a sec. Okay, so I converted the lengths of the sides of the pyramid in Edmonton. So I took 19.5 meters and I multiplied by 3.2808 because there's 3.2808 feet in 1 meter. So that gave me 63.9756. And then I took the 18 meters and I multiplied by 3.2808, which gave me 59.0544. I don't know what's wrong with my writing today. Okay, and then I found my volume. So 1/3 area of the base. So this is the area of the base right here. So that is that the area of the base? Hold on. Nope, sorry. This is the base length right here. This is the base length. All right, so I went 63.9756 squared times my height, which is 59.0544, which gave me a volume of 80,567.47 cubic feet. And then I had to find out how many times greater this one is. So I went and did 308,583 and 1/3 divided by 80,567.47, which gave me 3.8 times. So the pyramid at the Louvre is 3.8 times bigger than the one in Edmonton. Okay, so I hope that that helped. Again, ask me any questions that you might have. Okay.